Welcome to another episode of the Everyday Expertise Podcast. I'm your host, Roland Martin, and I hope that today's conversation will expand your knowledge. Today I welcome my father-in-law, Brian Cressman, to the show. Brian is an engineer who spends his time designing feed mill and grain systems for Camar Mill Systems, which is the same company that Jamie Shantz works for, who I had on the podcast a few weeks ago. We don't spend much time talking about Brian's current job, though, as he talks a lot about his experiences in the past. He talks about how he became an engineer and what his high school and university experience was like. And then he spends time talking about the former jobs that he's had. He spent a few years working for a very large company called 3M Canada, and then spent many years working for a smaller company that designed and sold an off-road vehicle called the Argo, and a few fascinating experiences there. Every time I sit down with Brian, I feel like I learn something new, and this conversation was no exception. I hope that you too will enjoy it and learn from his expertise. Welcome to the Everyday Expertise Podcast. It's really good to have you here.
I'm looking forward to this. I'm interested in this conversation.
Good, yeah. Well, I hope that it's something that interests you, which I know it is from conversations that we have past, talking about engineering and some of the experiences and things that you've learned over your career. So maybe to get started, what's your life looking like right now, or what are some of the things that keep you busy?
I was taking that as work related, and so I'm currently working for Camar Mill Systems. I think you had another guest.
Yeah, just a few weeks ago I had Jamie on talking about that.
So I work on the design side and as a project engineer, and my current projects are a new feed mill that's about half complete.
Okay.
And also a grain terminal ship loading project that's pretty well complete, just doing some final troubleshooting on it.
So it seems like it's a fairly narrow field what your work is within a kind of grain feed systems. I don't know how you describe it exactly.
It's agricultural industry and feed mills, but also the grain terminal side of things, so handling, shipping grain and things. So they're related in how materials are handled.
Yeah, that's true. But I was just thinking about it, and when you talk about your work and some of the different things that you do, I'm always amazed at some of the variety it seems there is within that very specific field or the very specific things that you're doing. So yeah, that's quite fascinating. But you've that's what you're working on currently. But we're also going to probably talk about some of the other experiences and some of the work that you've done. We'll get into that in a little bit. But you've had some different experiences and different types of work that you've done within your engineering field. So yeah, it's fascinating. Maybe kind of along with that then, talking about your work currently, or also thinking about other things that you've done. What are some of the tasks, or I ask here, what does a typical day of work look like for an engineer? So what does an engineer actually do?
Yeah, well, I took a bit of a cynical approach to that, and I said, well, it starts about 6 a.m. with the CBC news on COVID-19, and is there anything else happening in the world right now?
Yeah, good question.
But realistically, I get up fairly early, have breakfast, try to get to work by 7:30, and leave work at 5:30 or 5 o'clock or after. And in between there is when I do my job. So it's managing projects that are on the go, and that involves lots of computer time, sitting at a desk, two big monitors in front of me with up to a dozen or dozen and a half documents open at once. And typically email, CAD, computer-aided design, PDF document review. So we would look at review drawings and things done by the contractors working on our projects. And lots of phone time too with contractors and suppliers, follow up, project tracking, that kind of stuff. And then also site visits out of the office where we typically have site meetings with the projects every other week.
Okay.
So depending if there's more than one project on the go, you'll be out of the office more than every other week.
Okay. Yep.
And even between times too, following up on things.
Yep.
That's the job in a nutshell.
Yep. So in your work, so you're talking about your computer work, are you doing a lot of design yourself, or would you spend more of your time kind of reviewing what others have designed and making sure that it's I don't know, meeting specs or going to work or that kind of thing? So I don't know if the question makes sense.
No,
but
that's a really good question. There's lots of time spent in designing a project.
Okay.
But the designs that we produce are large overviews of it, and not always a lot of detail. Some of the machinery equipment in a mill, for example, gets detailed a lot.
Okay.
And could be a piece of machinery, a piece of equipment could be built from the design drawings for that.
Okay.
But most of the time, it's an overview of the whole process, the whole mill. And when the contracts are released, the contractors, in this case mostly millwright contractors, bid and have a responsibility to do the design and build of a lot of the equipment.
Okay.
So they will then submit their design drawings of specific things for our review.
Yep.
It's an extra set of eyes on it. They still have full responsibility to make sure it works.
Okay, got you. So are you, for instance, giving a contractor like space specifications that they can work within and their piece of
it's the overview. So on a feed mill, it's a like my boss says, it's a big machine. It's
the whole system.
The whole system is one big machine.
Yeah, I mean,
it's a big building with a whole bunch of interaction.
Yeah.
I always say a kernel of grain disappears into the start of the process at a pit where the truck dumps it, and you never see it again until it comes out as a pellet of feed.
Right.
To go in the truck to go to a farm.
Yeah. And whole process taking care of that. Yeah, fascinating. Yeah, and we got a little bit into that with in talking with Jamie a few weeks ago. A little bit about that. You could probably talk about some of those parts of the process and things a little bit more. But we'll see if we get into that a little further on as we talk about more about some of the things that you've done, some of the engineering work that you've been a part of. But maybe just a little bit more about you. Do you have any hobbies or interests outside of work that you'd like to share with us?
Sure. Outside of work and sleeping, the number of hours left in a person's life isn't as much as they think it is.
Yeah.
So I would say family and church rank up pretty highly in there. Just that involvement.
Yeah.
Love to do stuff like go hiking with the family. It doesn't happen near as often as it should. On a personal selfish interest, I like my mountain biking, trail riding. That I took up about 15 years ago when my son was getting old enough to get out and enjoy doing that kind of thing too. So
is that what pulled you into it? Like, was he interested into it?
I've always enjoyed bicycling
Mm-hmm.
from way back, but I didn't get out on the trails until then. I knew they existed out west of Kitchener, but we didn't try it until my son was about 10 or 11 years old or something.
Okay.
And then we tried it, and I really fell in love with that. It's fun,
Yeah.
but I don't get out that often. Once a week or so in the summertime, if I can, for half an hour or an hour.
Yeah, that's really neat. I remember one time you convinced me to. This was before Joey and I were dating or anything. Probably years before that, actually. I remember you convinced me to come out and try it one time, but it was not for me, or at least that time it wasn't.
I was always trying to rope the young guys from church in to come, and some love it, and I discovered you didn't particularly.
That's all right. It's not
which I find amusing because you love your running, which I can't really stand doing.
Yeah, yeah, and it's. I mean, people have different interests and things like that, which is great. That's and we can still get along and find things that we enjoy doing and enjoy talking about. So,
Yeah.
Yeah.
And other than that, so I mean, I don't want to dwell on this too long, but it's just in a lifetime of living, interests come and go.
Mm-hmm.
And people that know me today probably don't realize some of the things I've taken interests in the past. And
Okay.
I thought it might be interesting to people that know me a bit
Yeah.
to hear some of that.
Yeah.
I'm guessing there's some things here that even you don't
Yeah.
really know
Yeah.
about
I'm
me.
curious. What are some of these things?
So in the past, I've dabbled in all kinds of things. When I was young, I did some photography and stuff,
Okay.
including old school darkroom processing.
Really?
Yeah.
That I didn't
know if
know.
you knew
Wow.
that.
No.
Now, that was like when I was 10, 11, 12 years old and early teens. And I think the interest at that time would have rubbed off from my dad and my older siblings.
Okay.
So my dad had been into photography that way and set up a darkroom, and we used to develop our own film.
Wow.
Used to buy black and white film bulk and
Okay.
load our little canisters for the 35 millimeter cartridges.
Mm-hmm.
Take lots of pictures, develop the film, do the enlargements in the darkroom and stuff. And so I think back to that now, and I can't believe how that technology has changed.
Yeah.
But anyhow, that was one interest. A bit of hunting.
Mm-hmm.
A lot of people would probably look at me and go, really? But I did that. And in my younger years, ballistics and ammunition, reloading, that kind of stuff.
Okay.
And I was quite fascinated with that. And it probably fits with the technical engineering interests and stuff too.
Yeah.
Even before I was going to school for an engineer.
Yep.
Horse riding, grew up on a farm. We
Okay.
had a pony and a horse, and I used to use it as a means of transportation.
I see.
I'd come home from school, I was 12, 13, 14, and probably have a snack, run out to the barn, put a bridle on the pony, too impatient to use a saddle,
Okay.
jump on bareback and ride over to my friend's house, who was a kilometer and a half away in the country, and we'd play scrub softball
Okay.
for half an hour or something, and then I'd jump on the pony and rip home and
Wow. So
do the farm chores before supper.
was that your option instead of a bicycle, or did you?
No, I had a bicycle too,
You
but
just chose that over
well,
biking.
it was partly out of some obligation that you got a horse, it needs to stay exercised.
Right. Okay. So it was your way of
Yeah,
of getting the horse out.
doing my
Yeah.
duty, but it was all right too. It was fun, but
Yeah.
yeah, bareback.
Yeah. Wow.
We had a sail cart at one point. So
Like you sold things?
no, sail, SAIL.
Oh, like that was powered by the wind?
And I think that was an inspiration from a Popular Science article. that
Neat.
40 years ago, somebody was building these things with pedal power. And
Okay,
people would
yep.
go cross country with them. So
Wow.
the mast would be under 14 feet so they'd fit on a road.
Wow. And then they would pedal if the wind wasn't right. Or
Right. That
something?
was that was the thought. And so that was our inspiration to try it.
Wow,
And
that's
that's
neat.
something my brother and I did. I would say mostly my brother. He was older and more the machinist, shop guy.
Okay.
But we built this thing. It was fairly crude, but fairly effective. It didn't have pedal power, just sail.
Just sail. Yeah.
And I ended up doing the sailing because my other brother and I had owned a sailboat for a bit too.
Oh, okay. Are the principles the same?
Sailing,
Normally?
yeah,
Yeah.
totally. Cut across the wind.
Yeah.
So you need the wind to come across the road at the right angle, or you won't be sailing.
Okay.
If you can't go straight into the wind. You can go into the wind at a 30 to 40 degree angle.
Okay.
But I had a few good runs with it. It was very short-lived.
Okay.
Really pushing it at 20, 30 kilometers an hour, and it's three-wheeled with the front wheel out in front,
Okay.
and would actually be lifting the windward side with a sail. That's how you pull your sail in, just like if you're sailing a boat, to cut as much wind as you can with your sail
Okay.
and transfer as much power as you can to forward motion.
Yeah.
And I pushed it too hard and bent the mast at
Oh,
one point.
I
So
see.
that was the
Okay.
end of that venture, but
Yeah. You didn't.
it was good fun.
Yeah, I believe it. You took it out on the road?
Oh yeah,
Yeah.
country road.
Yeah. Do you like how do you go approximately the speed of the wind, or how fast would you be going at the most then?
In that kind of sailing, ice boat sailing, they can go 2 to 3 times the speed of the wind.
Okay.
So if you're cutting the wind at the right angle, and yeah, it's pretty cool. I mean, ice boat, I've never done that, but these guys go at crazy high speeds.
Yeah. Wow, that's fascinating. Yeah. Anything else that you had thought of there? Yeah, I'm learning new things about you.
I knew you would.
Yeah.
I mean, I used to like volleyball. Shoulders aren't working so good for that anymore. I did guitar playing when we first got married.
Okay.
My wife bought me a guitar.
Oh,
that was something I wanted to dabble in. And we lived in an apartment for a few years, and so I had time and spent lots of time just trying to learn to chord and
nice.
sing. And
just on your own, or
Yep.
Yep.
I actually had some colleagues at my job at the time that took an interest in that too, gave me some sheet music to look at.
Oh, neat.
But
Do you ever pull it out anymore?
Once every 2 years.
Okay, yeah.
It's pretty rare.
Should get you to do that sometime when we're over.
I hardly remember the chords anymore.
Yeah.
And
that's fascinating.
And my wife said, "Don't forget to mention you've sewed some of your own shirts."
Okay.
And I did that, I don't know, 20 years ago or something. And it was kind of fun. It's
nice.
Kind of a creative little thing, but it just takes time.
Yeah.
It's fun to do, but it does take time.
Yeah. Is it something you just wanted to try out?
I can't remember what the inspiration. I think the inspiration was the style of shirts that I like aren't readily available or something.
I see, yeah. So make your own.
So I saw this. Well, I probably was tagging along to the fabric shops or something, which isn't normally a guy's favorite activity, including me.
Yeah.
And probably browsing through some patterns, and I said, "That's the style of shirt I want."
Oh yeah. So make it yourself.
Yeah, it's way too much time spent on that.
No, that's fascinating, and it's interesting because it seems to kind of fit with your love of a lot of the things you were talking about there. Kind of fit with your love of tinkering, engineering, and so maybe you'll talk about this a little bit. But did some of that play into your choice for career and what you went to school for, etc., getting into engineering? Or?
I think we'll get into that shortly. I think, or maybe you're ready to talk about some of that.
Yeah, well, let's go into that. Kind of when did you decide to become an engineer? What were some of what led to that decision?
That's a good lead into that. So when I was in high school, I went to public high school. I went to public school all the way through, but public high school, I took a lot of shops courses. Again, I think following what my brothers had done, that was their interest, I would say. And in that era, there was a lot of that offered at the high schools. And I don't know if it is today. I haven't followed that. But back in the 70s and the 80s, there was just so much variety of shops courses, at least in our rural school out at Waterloo, Oxford.
Like you could learn any trade, basically?
You didn't learn a trade, but they were courses that reflected the trades being done, I guess. So there's woodworking and machine shop and drafting and electricity and electronics, and I think that kind of covers what was offered there. And I did them all. Like I took 2 or 3 years of drafting, 2 years of machine shop, woodworking, electricity, electronics, automotive. So by the time I got to grade 11, I was actually getting a little bit sick of that.
Okay.
And they did kind of follow a pattern. The course syllabus, I guess you'd call it. They would have almost half of it would be sort of book work where you read about a module of how to do something and then answer these rote questions, which really wasn't that academically challenging, but it was required to do the course, and part of your marks were on that.
Right.
So after you've done that a dozen times on a dozen different courses, and it's the same pattern, it's gets a little long in the tooth.
So was that what you were sick of rather than the hands-on part of it?
Yes.
Yeah.
Oh yeah. And the hands-on is so limited in a school course
Right,
like that.
yeah.
You spend the whole year and you make one little thing or something
Yeah.
like that. That was
And it's
pretty
very
common.
specified, right? Or
Yeah, you got to follow certain sequences and do stuff. But I mean, I don't want to diminish it. I'm really glad I did that because that gave me exposure to a whole bunch of stuff that you don't get at university. Like when you go take engineering, people think you learn how to do stuff, but you don't.
Okay. Yep.
My knowledge of how to do stuff came from that.
Interesting.
And experiences growing on the farm or just working.
Mm-hmm.
So by grade 11, I started doing I did the sort of the career education or interested ability inventories that they had available.
Okay. Yeah.
You'd probably be familiar with that, where you can, sign up and you get this. Well, back then it would have been paper, a whole inventory
Like,
of questions.
you answer questions and then
you do.
It kind of tells you what you
100
might be
different
interested
questions
in
or something, and it's kind of a psychological assessment. I don't know what it is. So I started that process with career counseling in grade 11 already.
Okay.
Because grade 12 was coming up, and back then we had grade 13.
Right.
So it was probably a bit early, but I'm glad I did it. Oh, the other thing is, at that point, I really wanted to be a pilot.
Oh, okay.
Commercial pilot. That was my career path.
That was your dream?
That's what I was gonna be. I lived, breathed, read, dreamt everything.
Okay.
Pilots. Bought a book. I say I probably knew how to fly without ever being behind the yoke of an airplane.
Okay. Mm-hmm.
And there's some truth in that, because you imagine yourself doing things and you learn how to do stuff that way.
Yeah. Yeah.
You got to physically do it at some point,
Right.
or you will crash. So I never did become a pilot, but it was definitely my interest. And my dad at the time, a little bit surprisingly, said, "You know what? You better go to university and get yourself a degree, because commercial pilots today, they have a decent education."
Okay.
And so somewhat surprising, because nobody in my family or history had a degree. I shouldn't say that. My aunt did.
Okay.
Had a degree from the
But
state.
it wasn't something everyone did in your family, obviously.
Oh no! Well, in our community too, right?
Yeah.
It was
Yeah.
in our church, somewhat common, but not in the broader community we're from, Mennonite community.
Right.
So it was a different thought. So then I started doing this grade 11 career exploration,
Mm-hmm.
and getting a little bit tired of the shops courses.
Right.
So by grade 11, 12, the academic stuff was more tolerable. I'll say it that way.
Okay.
I wouldn't say I love school.
Yeah.
But it was definitely interesting and more tolerable. And the math and sciences were obviously what I was better at.
Mm-hmm.
English, history, geography. I wasn't terrible at, but I couldn't ace them.
Right.
And so, if you get B's and C's and you're used to better than that, it doesn't feel very good.
Yeah. Yeah.
I find history and geography and fascinating. It's interesting. And at university, I took 2 psychology courses.
Okay. Yeah.
Fantastic, interesting stuff.
Yeah.
Amazed that people can spend a lifetime studying this stuff. But,
Yep.
I get it.
Yeah.
But it wasn't my bent, I think.
Okay. Yeah.
So grade 12, 13, I really focused on the maths and sciences. Got one of the grade 13 courses out of the way in grade 12. I think it was biology. Picked my least favorite. And I needed that, surprisingly, for engineering at University of Guelph. Entrance requirement for the agricultural engineering program, you needed a biology, grade 13 biology.
Okay. Yeah.
And I don't think any other engineering program anywhere requires it. So I sucked it up, took it, and got it out of the way. And then grade 13 focused on the 3 maths and physics and chemistry, and then did the application process to Waterloo and Guelph. I think that's all.
So were you planning to do agricultural engineering in high school already, or?
No. Yeah, good, very good question. So, because we're jumping ahead there a bit. No, I didn't really think I was going to work as an engineer.
Okay.
I thought
Yeah.
I'd probably be a farmer or whatever. I don't know.
Okay. Were you
Which
still
is
thinking
fine.
pilot at that point?
Oh yeah.
Yeah.
Oh yeah. Sorry, I was definitely thinking pilot.
Yep.
Um.
So even when you were applying to
Yep.
for a university degree,
Yep.
to get into university, you were still planning ahead to.
Well, planning ahead. It was still in my mind for sure.
Yeah.
But engineering is a fantastic education. That's you don't close doors with an engineering degree.
Okay.
Generally, lots of people. Some people will you have an engineering degree as their undergrad to go into medicine.
Oh,
I
okay.
mean,
Yeah.
most people wouldn't think of that, and they probably have to pick up some courses that they wouldn't get as an undergrad in engineering, but it's definitely a path that can be taken. Teaching, just there's all
Right.
kinds of stuff. Lawyers.
Okay.
You know, an engineering degree is a great undergrad degree to go into law.
I see.
You'll probably specialize in an area of law that will pull from your technical
Okay. Yeah.
training, but it's a really good broad degree. Whereas if a person chooses, history or social science or maybe even general science or something like that, it does somewhat limit what you're going to do when you're done with that degree.
Yeah.
So it's a good broad education. It's not easy, and some people choose it because they know they want to be an engineer, and that's great.
Yeah.
I wouldn't say that was me.
Okay.
I took it because it was a good education to take, and it leaves your options open.
Yeah. Yeah.
So if you're undecided and you want to keep as many doors open, that would be the story of my life, I'd say.
Were you were guidance counselors telling you that? Like, is that kind of where you had that idea? Or?
Yeah. Interestingly, the guidance counselor I had almost discouraged me.
Okay.
He says, "Oh, are you sure you want to do that? It's pretty heavy stuff." And I'm like, "Well, yeah."
Yeah. Okay.
I think so.
Okay. Yeah. So you had kind of decided on your own that was
If I'm going to do it,
path.
that's what I was going to do. Yeah. And it matched my interest and abilities.
Right. Yeah.
More than anything else, really.
Yeah.
I suppose if flying pilot was available as a degree or diploma at that time, well, actually, it was available as a diploma. So I wanted to comment on this. I had a friend, a neighborhood friend that we did a lot of stuff together with at the time, who actually did go and become a pilot.
Okay.
He's been a commercial pilot for our whole career. He's exactly my age, and so he did it. And there was subsidized programs at Seneca College. I think it still exists today.
Okay.
Very difficult to get into. Was even difficult then, but he took a year or two, I think 1 year of university first, and then transferred into that program.
Okay. Yeah.
Graduated. So that was happening. I probably could have done that, but a little shy of having to go to school in Toronto, middle of Toronto.
Oh, yeah.
Seneca College. As a 18, 19 year
Right.
old.
So you were thinking about location as was a factor.
Yeah. I mean,
in
we're blessed with some world class universities in our backyard.
Yeah.
It's amazing.
Mm-hmm.
So applied to Waterloo and Guelph. Was actually accepted at both, and was kind of torn. But the thing that just tipped me over the edge ever so slightly was an entrance scholarship at Guelph.
Oh, yeah.
And Waterloo was already, at that time, sort of the renowned engineering school in Canada.
Okay.
My dad, farmer, gently encouraged me to consider Guelph, and he would have known of Guelph through, if it was OMAF at the time, I don't know, Ontario Ministry of Agriculture and Food. They would have speakers and stuff at agriculture events and stuff. Yeah. So he knew of people that worked there, came from there, and it is a friendlier, smaller type university.
Right,
The Waterloo's kind of a concrete jungle.
Yeah. And is University of Guelph, was it known at the time for its agriculture program?
That's University of Guelph started as an agriculture school.
Yeah.
So it's 130 years old as Ontario Agriculture College.
Okay.
I don't know if it's somewhere in that, like it's old, and became a university I won't get my facts right on that, but
yeah.
Ontario Agriculture College, eventually when it became University of Guelph, the college, they're kind of the same thing at that point.
Yeah,
whatever.
okay.
So then there were degree programs in agriculture, business, agriculture, science, that kind of stuff. And the engineering school started then too in the 50s or 60s as part of Ontario Agriculture College.
Okay.
So people that wanted an engineering degree would take, kind of moving into the the university part already, which is fine. So that's what I accepted. I went to Guelph, accepted the offer to go there, and people before I went there in the 80s, I'd say about the 70s, it was an Ontario Agriculture College where you could get an engineering degree, but you had to finish it with the University of Toronto.
Oh, okay.
So I think fourth year for sure, maybe third year too, you had to have courses from University of Toronto, and then you got your engineering degree with an agricultural bent.
Yeah.
So I went there from 83 to 87 in agricultural engineering. There were 3 majors offered.
Okay.
The other 2 were water resources engineering and biological engineering.
Okay.
So they were a very unique little school.
Yeah.
None of those, no. I know agricultural engineering no longer was offered after sometime in the 90s. I think.
Oh, okay.
But they've expanded the program immensely. We had 50 graduating students from all 3 disciplines in a year.
Okay.
Today, I think they're 250 or 300.
Oh, wow.
Or more.
Okay.
They've grown it dramatically, and they've offered traditional programs now of mechanical engineering and computer engineering, that kind of stuff. The reason agriculture engineering would have been still offered and relevant was there were still farm machinery manufacturers in Ontario.
Okay.
So John Deere was still big down in Welland, Ontario. I forget which of the International Harvester or Massey Ferguson, or maybe both, were still present, I think in Brantford, and just at the verge of dying as manufacturers in Ontario.
So that's what this program would have been preparing a lot of people for? Or?
It certainly, that's why it was there.
Yeah.
So people would, there'd be engineers with with a focus on agriculture that would be attractive, I think, to those kind of businesses. I mean, that's one small thing. So agricultural engineering is kind of a cross between civil and mechanical.
Okay.
Mechanical engineering would be the discipline to design machinery and things, equipment, whereas civil engineering is buildings, bridges, roads, whatever. In the agriculture engineering field, the civil part of it would be buildings, farm buildings.
Yep. So you were learning about those kinds of engineering?
You could. You had, in your electives, you would steer your degree towards your interests.
Okay.
So I had a course on wood and concrete design.
Okay.
And but my interest was in equipment and machinery.
Okay. Yeah.
So I would have focused on that more. So I finished that degree in 87 and still didn't know what I want to do. Every summer, so it was a conventional 4-year honors degree.
Right.
And through the school year, summers off. Every summer I went home and worked on the farm.
Okay, yep.
And Dad used to say, if you work, you might get paid. If you don't work, you don't get paid. And so typically at the end of the summer, we had a mixed farm with pigs and beef cattle and cash crop. And at the end of the summer, we'd get to ship a load or 2 of pigs and get the proceeds from that. So it was kind of your own business. It wasn't a paycheck type of thing. So you got paid once a year. You learned how to make that last the year. And surprisingly, it did when my annual university costs were $3,500 up to $4,500, including my room and board and
Wow.
golf.
Wow.
But you know me a bit, and I am frugal.
Yeah.
And I had a car to use to get to school and back.
Okay. Like your dad owned it,
Yeah,
or
yeah. And I think I paid the gas in it or something. But
Okay. So you were able to.
I was subsidized in that way.
Okay. Yeah, and you were able to pay for your university as you were going through it with I was working on the farm in the summer and.
Yep.
Nice. Yeah.
Yep. So I was able to pay that. I'd probably saved some money by then, even before going to school.
Mm-hmm.
So where I ended up pretty much at zero was at third year. Took that trip with my brother and sister, and my aunt back to Africa. So
Right.
Gone
Yeah.
for 10 weeks, so I didn't make as much that
Yeah.
summer.
Wow. So that was most of the summer. That
Yeah,
you
it
were
was,
gone. Yeah.
yeah.
Well, very good. So you got to the end of your undergrad, and you still weren't sure
Yes.
where you were going with that?
Correct.
Okay.
So by the end of fourth year, there were scholarships you could apply for to continue your education.
Mm-hmm.
So
Like a master's degree? Or,
Yep.
Yeah.
NSERC. And there was an Ontario one. NSERC is Natural Sciences and Engineering Research Council. So
Okay.
Federal agency. And they have scholarships available pretty much based on your marks
Mm-hmm.
at undergrad. And there was an Ontario one too. So I did the smart thing, keeping my doors open.
Yep.
Put my applications in January, February, or something like that. And was awarded or offered an award to extend my education.
Okay.
To continue.
Yep.
And they're not trivial. At that point, there's $10,000 a year, and we're talking in late 80s.
Wow.
So it's not a wage, but
Getting paid
it
to
covers
go to
all your
school.
costs,
Yeah.
especially if you're living at home.
Yeah.
So the motivation to go find work wasn't as high as it could have been.
Yeah. I was, well, even though that you were able to pay for your schooling, so there wasn't that motivation as much when you were done either. So I was wondering if that figured into you continuing on after your undergrad.
So I did half-heartedly, I would say, put a job application out, one or two, I don't know.
Okay.
Had an interview, and the guy, it's kind of interesting. I won't name the business. I think it might still exist. The guy who ran it still exists, but I learned since it's a little funny.
Okay.
So he looked and he says, well, I don't think it's quite the best fit. But, if you want to work here for the summer, we could use somebody on the floor here and helping to build this equipment and stuff like that.
Mm-hmm.
And I think he offered me like $5 an hour.
Wow.
Which was a minimum wage type thing at the time.
Okay.
And I'm like, yeah, I don't think so. I just didn't seem right. It was half an hour from home. And so, and with already having a scholarship to continue, normally when you would enter a master's program at Waterloo or Guelph or anywhere, you would need to find a sponsoring professor. You'd want to find a sponsoring professor.
Okay.
You could go sign up and take courses and just pay your own way. But in the engineering field, if you can find a sponsorship by a professor, then they will provide funding to you directly to have your help with their research.
Oh, okay.
So they get funding to do research
right
that they then administer by getting grad students to work on their projects.
Yeah.
So that would be normal, but that's a process you'd have to start early and take what you can get.
Yeah.
With the scholarship, and they all told me this says you can do whatever you want. You can go anywhere and they'll take you because you're funded.
Okay.
And so I worked on the farm all summer till about end of July or something. I said, man, I better get on this if I'm going to do something.
So you still weren't sure what you were, like if you're going
to kind
to go or continue
Kinda.
schooling?
Yeah, kind of.
Yeah, interesting.
So I did call up at Waterloo then and went in and talked and signed up.
Okay.
Got a professor that would be my supervisor. He didn't have too many grad students at the time, but and picked an area to focus on. So a master's degree, you can choose a coursework master's or a research master's.
Okay.
Coursework master's requires 8 grad courses
Okay.
completed and a project, written project. Research master's requires 4 courses, which isn't really much.
Right.
And a thesis, a research.
Okay. Yep.
Some research and a thesis. And so the advice these guys gave me was, you know what, do a research master's, because with a coursework master's, you're not eligible to go to enter a PhD program.
Oh, okay.
You need a research.
You need a research one, yeah.
And he says most people that do the coursework masters end up doing a project that's pretty much a thesis.
Oh,
anyhow.
I see.
So their take on it was do the research masters.
Yep.
So that's what I did, and picked up half a dozen courses of higher level engineering work. Interestingly, so this is the late 80s, one of the courses I got a grad credit for was solid modeling. So it was cutting edge stuff, doing 3D modeling.
Okay.
Today, I don't think you'd even get a credit in a first year course for that.
Okay.
I got a grad credit for
Wow.
that. But you earned it because you're working on VAX workstations, terminals linked to a central computer
Okay.
that a dozen other people were using, and you're trying to do solid modeling, which is computer intensive
Right.
operations, and it took forever to do the simplest thing.
So it was just a lot of work because of the computing
no,
power? Or?
no, it was just tedious.
Yeah, yeah.
It was tedious, but it's amusing that I actually got a grad credit for doing CAD solid modeling.
So did you do a specific thesis or area of research during that time too, or?
Sort of.
Okay.
So I had this personal invention of mine that I wanted to pursue
Okay.
that found its way on paper only ever.
Okay. So is there a lot of leeway in what you can choose, kind of what
It's got to
what you're
be.
interested
It's
in?
got to be technically in depth enough to qualify. And,
Okay,
And your supervisor and two other professors will decide if that's sufficient to earn a degree.
Okay. Yep.
So my idea was a topography conforming lawnmower.
Ah.
And it was borrowed from the idea of these farm hay mowers that use disc mowers, and they're pretty common today. Guys have these for cutting their alfalfa.
Okay.
And nowadays they're big machines. They mount on a tractor, and they put wings out each side and out the front, and run at like 10, 15 kilometers an hour through the field, cutting down.
Okay.
hay.
Yeah.
It's incredible what they've done today with them.
Wow.
But they're not topography conforming. They're fixed discs that spin, cut the grass.
Okay.
And my thought was, let's make a disc that can actually conform to the mower. Because I'd cut the grass at the farm there for 10 years prior to that with a ride-on mower, and we always did like a couple acres of mowing. It took hours, and you scalped grass, and
Yeah.
we're gonna improve on
So
that.
your idea was no matter how many bumps and stuff there
Yeah,
are, you could
that's
have
the
a
idea.
perfectly even cut.
So that was the concept.
That's awesome. Yeah.
But to make it a research thesis, you got to get pretty deep.
Okay.
And so my professor steered me in the direction of doing the advanced dynamics analysis of that
Okay.
spinning head. So what happens? And he says, you could build something in your home shop there and validate what's happening. And he was encouraging me to do that, but I never did it.
Oh, okay.
But basically did the deep dive in the math and dynamics of analyzing this thing to the point of writing my own Fortran code
Wow.
to do the analysis of it.
Yeah.
Don't ask me anything about it. I can show you this thesis. I won't be able to explain it anymore.
Okay. So was this something that you loved doing, or were you doing it because you had to kind of at that point?
It was a burden. It was
Yeah.
And the thing about a master's thesis is it's a writing exercise. And
Okay.
it's pretty big.
Yeah.
And my professor there was more red on the page than black when he reviewed
Okay.
stuff. And he had to push me pretty hard to get going on. He said, you got to get going on the writing. Start writing. Write a chapter.
Yeah.
And then he'd review it. And I remember him making fun of me. Well, not making fun of me at once, but his gentle criticism. He says, I don't know if it's your Pennsylvania Dutch background or your rural stuff, but your sentences are awkward and they're always a little bit backwards.
So he wasn't necessarily critiquing like the technical part. It was the writing part of it.
He was focused on the writing being good, and that was a valuable exercise. The master's degree did more. I think it did more to help me write concisely.
Yeah.
And
it was
communicate well.
It was almost a communication degree, communication degree.
It was.
That's fascinating. Yeah.
Others that read my stuff might not agree, but and I don't write a lot, so my writing is very brief. If I write something, it's strictly to communicate something in as few words as possible, as clearly as possible, without being ambiguous.
Yep.
Not always successful.
Yep. So you did that. How long did it take you to?
So I was 2
years. You finished that degree, right? The master's degree.
Yeah. So that was in 1989. Yep. I was turning 25 in 1989. My wife and I were dating at the time. So 1989, I finished that degree. I started my first job. We got married. We moved to London to an apartment. You're not supposed to have too many change things in 1 year. Yeah. We blew it that year. We did it all in 1 year.
Wow.
So as I was finishing up, now I knew, well, and thinking of planning, already engaged to get married.
Okay.
I had to get a job.
Yeah.
Got to get a real job. So put applications out a couple places. Actually had an interview in Peterborough at General Electric. Large motor manufacturer.
Yeah.
They make motors for ships and turbines and stuff. It's, I think, just in the last few years closed or reduced their size dramatically.
Okay.
Certainly would have been fascinating, but it was very specific engineering stuff.
Okay.
Doing the detailed design on large motors that would literally fill a bedroom. Yeah. Shaft analysis, that kind of stuff. And 3 hours from home community.
Yeah.
So these well, I did not get that offer anyhow.
Okay.
But went for the interview, which was interesting. The choices in your life, the whys in the road, paths taken, it's interesting. How would my life have been different had that been an offer and I had taken it?
Yep.
Who knows?
Yeah.
God knows, I guess. Had an interview at Cami Automotive. And that was a fascinating process to go through the interview.
Okay.
Team interviews.
Really?
4 or 5
wow.
people and 3, 4, 5 people watching and
wow.
doing these little exercises. And I'm too busy sitting there watching the process thinking, I wonder what they're watching for. I wonder what they're doing. So I didn't get an offer there either.
It's interesting. Wow.
And you know what? I don't think I would have been happy doing that.
Okay.
So it's manufacturing engineering. You're helping make a plant go.
Right.
And so maybe the interviewers knew their stuff. Said, this guy's not going to be happy here. I don't know. And then the interview with 3M Canada. The guy actually came to Waterloo and did the interviews there.
Oh, okay.
And pretty much offered me a job on the spot.
Oh.
In the first interview. Or invited me down for a second interview.
Okay.
I had applied for product development at 3M.
Okay.
Thinking I want to develop products.
Yeah.
But product development at 3M is chemistry.
Right, because they're doing adhesives and well, they do a lot of things,
all
I guess,
kinds of stuff. Yeah. But in Canada, they'd be more interested in a chemical engineer.
Okay.
Or straight chemistry person. But my interview obviously found it across his desk, and so he came and interviewed me. He says, I think you'd be a way better fit in division engineering, it was called.
Okay.
And I'd really like you to come down, and so I did. Went down, had an interview, and he offered me a job on the spot.
Nice. That's
where I ended up for 4.5 years.
Okay. And so you said you weren't developing products, so what kind of was your role there?
So 3M Canada Engineering was project engineering, similar to what I'm doing today.
Okay. Yeah.
So between then, the 4.5 years I spent there, and Camar Mill System, where I've been 4.5 years, spent over 22 years at Ontario Driving Gear Argo, which was product development.
Okay.
But first, the 3M job was project engineering, where the plants, factories, and 3M had like 5 of them in Canada.
Oh, really? Okay.
The biggest one in London.
Yep.
Needed support to keep their factories up to date, improved, expanded, whatever was happening.
Yep.
So I was a junior guy. I actually started as what they had very structured job descriptions.
Okay.
Because it's a big organization.
Yeah.
I mean, yeah, that's another interesting thing. I've worked now for companies, a multinational 3M company had 1,500 employees in Canada and 60,000 worldwide.
Yeah.
And then I moved to a company with 50.
Yeah.
That grew to 250 while I was there. And now I started at one 4.5 years ago that has less than 10.
Yeah.
Had less than 10. So
You've seen them all now.
My
All
world
the
shrunk
sizes.
dramatically in 30
Yeah.
years. But at 3M Canada, the plants would have a need, or a division of the plant would have a need to replace a machine, develop a machine, set up a whole new production line of making masking tape or producing adhesive. So they would put in a request for engineering services to
Okay.
division engineering.
So it was a big enough company that
Oh, it's huge.
they could support their own
Yep.
engineering
Yep.
consulting team.
Yep. Pretty much. And our office had 30 to 40 engineers, technicians, technologists,
Okay.
which was a fantastic place to start the career, because there was always somebody to ask a question of.
Oh, yeah.
You didn't know how to do something, you just go ask.
Mm-hmm.
And there were 3 managers. The one that hired me was my boss. And so he would get the requests from his areas of the plants that he was responsible to support.
Yep.
And then he'd decide who he's going to assign it to.
Mm-hmm.
An interesting thing about that job, too, is every new employee that came in, they were hiring several a year
Okay.
all the time, because
Yep.
they had to support that size of staff.
Right, yeah.
Each new employee got assigned a senior mentor,
Oh, okay.
so that the supervisor, the boss, didn't have to do it all.
Yeah.
And so I had this older guy who I'm sure wasn't as old as I am now, and he was fantastic. And, we were good friends, and a project assigned to me, he would have responsibility for it.
Okay.
Too,
Yep.
right? And he would walk me through it and learn all the things you have to do the job. So I had some projects in the plant at London, just little stuff, and also at Perth, Ontario.
Okay.
Up near Ottawa, an hour out of Ottawa.
Oh, wow. Okay.
They had a packaging tape producing plant there, and diaper tape.
Oh, okay.
So in the first week, I think my mentor, Peter, said, we're going to head to Perth, and we fly out of London Airport. We land in Ottawa. We rent a car. We drive out, do our thing, drive back to the airport, fly home.
This is all in one day? Or
Yep.
not? Okay.
It was common. So you catch 6:30 flight out of London in a Dash 8, and have your coffee on the way up there, and land an hour later, and rent your car and jump in and drive an hour out to Perth. So you were about 4 hours in transit
Yeah.
to get to the plant, and you could drive there in 6, I think.
Okay.
But
Saved a little bit of time.
that's how they did it, and it was horribly expensive, but that was the corporate world back then.
Okay.
To some extent is today too, except not right now.
Right, yeah.
So I did have a couple of projects there, and I guess, you asked about some interesting ones, and you might have heard the story before yourself, but one was diaper tape hole detector. So they had this film extrusion line
Okay.
that produces white plastic film, 5 feet wide, and runs continuously, 100 feet a minute
Okay.
or something. It's not super fast, but it's producing plastic film that was then used to make the little fastening tapes on diapers before they went to hook and loop style.
Okay.
The diapers you would use now on your son would be hook and loop, I think, because the sticky tape that we had when we were raising our kids, if you placed it wrong, it stuck on their skin.
Oh, okay. Yeah.
But that's what they were producing at the time. And the problem was, occasionally the extruder might leave a little tiny hole.
Oh, I see.
Well, you think, big deal. What's a hole in a 5-foot wide piece of film
Right,
going
yeah.
100 feet per minute?
Yeah.
But that film got cut up into little strips 1 inch by 4 inch.
Oh, okay.
And some mom's going to, her dad's going to take their diaper and go, what defect? Johnson doesn't like to have defects.
Yeah.
So we had to get a hole detector, and it was a device developed by 3M Labs in St. Paul.
Okay.
So it wasn't a purchased item. They had developed it, and the request came from the plant at Perth that they need a hole detector, and so I got assigned the project and had to do the legwork to figure out where it's going to go on the machine.
Okay. Wow.
Liaise with the guys in St. Paul that had developed it, which were actually researcher lab type guys.
Okay.
But it was a line scan camera like we would take for granted today
Okay.
with digital stuff. But this is 1989, and did that project, and that was all happening just before our wedding. So big joke, yeah, Brian's working on a diaper hole detector, diaper tape hole detector.
So you were doing like quality control? Things
No,
like that?
it was coordinating the purchase, auxiliary design of mounting this thing,
Right. Yeah.
and then the actual installation. So if the plant didn't have their own maintenance guys, and you hire a contractor, make it happen.
Okay. Yep. You were in charge
and
of
then yep,
organizing that?
yep, and then the training too. So the guys came up from St. Paul, and so just coordinate all that, make it happen.
Okay.
And that's kind of what project engineering is.
Okay.
Coordination, scheduling, making things run smooth so that the owner, whatever that is, if it's a manager of a plant or the owner of a feed mill, doesn't have to worry about it.
Yeah.
He has somebody that keeps it in control, and he can depend on it. And if there's any question comes up, he comes to that guy instead of going to all the people that are doing the work.
Yep.
And that's the same thing at 3M there too.
Okay. So you were working there. You were there for, you said, 4.5 years. Yeah. Was it always just a temporary thing, or were you thinking that you're going to move on to something else at some point, or were you planning to?
That's a good question.
We were
living in an apartment in the city, and we're not city people.
Right. Yeah.
We didn't spend that many weekends. No, I shouldn't say that. We were back for church in our home area.
Okay.
Like New Hamburg area. Every single weekend except about 2.
Okay.
Half the time it was get up Sunday morning and go, but the other time we didn't have children yet. The other times it was go and stay with one of our 2 parents over Saturday night or even longer, like a whole weekend.
Right.
So we never, we lived there, but we never really lived there.
Yeah.
It was home away from home. So when, and we were ready to buy a house. So when a house came up in Tavistock, closer to our home area, we bought that, and I commuted, and it was only 50 minutes, like 50.
Yeah.
50 minutes, which in commuting terms today is nothing, and it wasn't really then either, but it was for London. People in London couldn't get it.
Oh, really? Okay.
You drive almost an hour. And I said, oh, you have no idea. People in Kitchener-Waterloo area drive for more than that.
Yeah.
Every day, all the time. But it's still not nice.
Yeah.
I did it. It was a wonderful drive, back roads, not highways.
So it wasn't stressful.
Nope.
Yeah.
Nope. But it's still
It's
almost 2 hours out of your day, every day.
Yeah.
And I did it for a year and a half.
Okay.
Before the ad came up for Ontario Drive-In Gear in New Hamburg, where they make the Argo vehicle. And I didn't see it. My parents saw it in the newspaper.
Oh, okay.
Which is why today when we're recruiting, I even like to get ads in papers. I said, I'm not targeting the the young people we're trying to hire. I'm targeting their parents and grandparents who want to
Interesting.
get them back home. And it works.
Okay,
You know?
yeah.
In that case, it did. My parents said, "Hey, there's an ad in the paper. You should look at it."
Were you familiar with ODG?
Slightly.
Okay.
That's a good question because in grade 11, high school,
Mm-hmm.
we're going to take a little segue.
Yeah.
Bunny trail here. The high schools had a work experience program that people could do if their marks were good enough, blah, blah, blah. So at
Okay.
the end of the year, you could go for 3 weeks and work for some business
Oh, okay.
for free,
Mhm.
but get some experience. But you got out of school and you got out of exams.
Oh, okay. Yep.
Back in that day, you would get out of final exams anyhow if your marks were good enough.
Right.
So you had to qualify for that, and then you could also knock off school 3 weeks early and go work.
Okay.
So I did that at ODG, Ontario
Oh.
Driving Gear.
Where you ended up working then later.
Yeah,
Interesting.
yeah. My brother had done the same thing there, I think. Oh,
Okay.
that might not be right, but I did it there.
Yeah.
But I mean, I was stuck in the machine shop running the machine.
Okay.
Put a part in, take it out, put a part in, take it out.
Yeah.
All day long. I think towards the end, I requested and the marketing guy took me for a ride in the Argo up and down the driveway or something like that.
Nice. Yeah.
And I'm pretty sure it was a guy I later worked with. He
Nice.
was younger then.
Right. So anyway, you
So-
applied to this local
Yes.
job?
So the ad came up in the paper. I put in my application and got a call. Said, "Could you come for an interview?" And so I did. And after the fact, I learned that I was actually the last guy in sort of an add-on interview.
Oh, okay.
That they had already interviewed. They already had a short list of people they were trying to choose from.
By the time you applied, or
Yeah.
by the time you interviewed?
Well, yeah, one or the other.
Yeah.
Oh, the other thing is I had an I forgot this. I had an application in a sandpaper factory in Plattsville that's since closed.
Okay.
Just as an engineering job, manufacturing engineer, and it wouldn't have been great.
Okay. Yeah.
And I had an interview there the same day as my second interview at ODG.
Okay.
So I ended up calling ODG knowing that a second interview sometimes means an offer.
Mm-hmm.
Saying, "Can we move that one ahead to like 8 a.m.?" So, yeah, the second interview, he offered me a job,
Mm-hmm.
which I accepted. And then I basically, I didn't even have time to call. It was before cell phones, right? So I drove down to Plattsville, walked in and said, "You know what? I just accepted the job offer." Well, thank you for telling us. So the ODG one, I mean, that's for a person that's interested in product design, mobile equipment, an ATV. So the Argo is a 6-wheel or 8-wheel amphibious all-terrain vehicle. That's what they make, and they're made right in New Hamburg.
And they were doing that already when you...
They were doing that since
Even before, long before you started there, right?
72.
Oh, yeah, okay.
1967.
Oh, wow.
And in New Hamburg since that time. So this is my backyard.
Yeah.
And even I worked there the 3 weeks, volunteer. But in the interview, the owner, a German immigrant guy with very good English, better English than most of the people that work for him. He was always correcting our grammar.
Yeah.
Not always, but he was definitely sensitive to it because he learned it as a second language.
Wow, yeah. That's neat.
But in the interview, he says, "Any questions?" And I says, "Yeah, who do you report to?" "Oh, I own the company."
Like, you didn't realize this?
I didn't know that.
Oh, okay. Yeah.
To me, I thought it was a subsidiary of some company somewhere else in the world, right? So that was pretty interesting.
So he wasn't offended by that?
I don't think so.
Okay.
Well, I don't know. It was later, and at the risk of him actually listening to this someday, I'll say it anyhow. It was later in a management meeting. I was part of a management team at that point. In a management meeting, his assistant came and interrupted our meeting and says, "There's a phone call for you." He says, "Oh, who is it?" "It's your father." "Oh, I gotta go." I said, he does report to somebody. Father in Germany.
So did they do more than just produce the Argo? Like was there other things that they did too?
So that was the end of my tenure at 3M.
Right.
And when do you want a funny story about 3M?
Yeah, for sure.
It's long enough ago I could tell it. We'll come back to the transition.
Sounds good.
At 3M, the engineers, technicians, technologists in our department were all in a separate office in the same plant complex, but off the end of to the right of the main entrance where guards sat guarding the place.
Okay.
Full-time guard duty, union plant. Plant employees came in the front door, went to the left down the hallway to the factory, where there were a couple different production areas, masking tape production. Another whole area was sandpaper production.
Okay.
Another whole area was adhesives, sealants production, where they're goopy, sticky stuff being made.
Yeah.
Big maintenance department in the back. So in my 4.5 years at 3M Canada, I got to know like literally hundreds of people.
Okay.
It's unbelievable. I mean, they had internal email where we used it constantly
Okay.
to communicate and stuff. And between the plant in London, Perth, people in St. Paul, Minneapolis, St. Paul, some international trips I took doing work for that projects, I knew so many people.
Wow.
My world shrunk after that.
Okay.
And in the office, there was a fairly informal atmosphere, morning coffee. People would kind of stand up and chit chat for 10 minutes or something like that. It was really, really neat.
Interesting. Yeah.
And I ride unicycle. I have a unicycle.
Okay.
And so I actually took it and stored it under my desk.
Okay.
And then occasionally, once a week or whatever, at the informal little break time, I'd get my unicycle out and ride up and down the aisles of the cubicles. It's open office with cubicles that are 5 feet high.
Okay. Yep.
And people used to, if they reminisce, they chuckle about how they just see my head riding past the cubicles.
And you just thought this would be like when you started doing it would just be a funny thing to do? Or
Yeah,
what?
yeah. And that's all it was too, yeah.
Yeah, it's great.
That was when I was young. So, on my last day there, or I should say, I went and made gave my resignation letter to my boss, and of course he's disappointed. But he says, we bought that house at Tavistock. I said, okay, it's just a matter of time.
Oh, saw the writing on the wall.
And 3M was a good place to make a career. Like the story then was, once a 3M'er, always a 3M'er, and it really. So
they had a good workplace environment. Like people liked working there.
It was just a large corporate mother,
Yeah.
I think it changed after I left. There was some financial stress, and they started pressuring departments to, filter out deadwood, if you want to call it that, whatever, and replenish things.
Get a little leaner.
Yeah.
Kind of thing. Yeah.
Yeah, that did happen after, but I didn't stay connected there much.
Okay.
After leaving. So my farewell day, or my last day there, I took my unicycle, and I want to go say goodbye to all the people in the plant. I mean, you develop relationships with so many people.
Yeah.
So I took my unicycle, and I rode it around the plant.
Neat.
And I rode way back to the maintenance department. I don't think they had ever seen it. Say goodbye. I'm leaving. I'm going to this other job. Blah 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 blah. And all the different departments, and then I ended up in the plant offices where the plant manager sat, and they had a few engineering staff and quality people and stuff like that. Say goodbye to them, and I'm saying goodbye to the plant manager, and he says, "You didn't ride that thing in the plant, did you?" And the guy's got no sense of humor, like literally zero sense of humor. I'm like, "Yeah." He says, "Don't ride that in the plant." I said, "Oh, okay." So I carried it out of there, or wheeled it out of there, to the exit hallway to the guard's desk, where you didn't need PPE in the exit hallway. Inside the plant, you needed safety glasses.
Yeah.
So in the exit hallway, I got on it, rode it back, past the guard's desk, up to the offices, whatever. And just put it away, just took my cup to go get coffee, and here comes Mr. Plant Manager stalking into the office. He says, I want to see you in Dave's office.
What?
I was like, what? Okay. Well, my boss is away that day.
Okay. Is that Dave?
Yeah.
Your boss? Yeah. Okay.
So he grabs one of the other managers, and he was livid. He was
wow.
really upset. Because he felt I had defied him.
Oh,
I didn't
see.
feel I had. I
Yeah.
felt like, anyhow, it was not a happy ending.
No,
to that.
well,
It's crazy.
So was he
Yeah.
he knew that you were quitting?
He knew it was my last day.
Okay, yeah.
The other manager that got dragged into it, he that was awkward for him.
Yeah.
But he says, he met me privately then. He says, he actually wants to fire you. He wants you to be
Wow.
dismissed. I says, are you serious?
This is your very
So
last
he
day.
sent me home early.
Okay.
It was like 10:30, 11 in the
Wow.
morning. The guys are going to take me out for lunch.
Wow. So you've actually been fired.
Nope, it wasn't fired.
Okay, so it wasn't officially that.
It wasn't officially fired.
Wow.
It's long enough ago, I think I could talk about it.
Yeah.
And later, enough weeks went by, or a month or two, I forget when. I wrote him a letter and said, I'm sorry it happened this way. I'd really like to clear this up, blah, blah, blah. Never heard of it.
Really? Wow.
No sense of humor.
Yeah. So did it leave? Did you feel really bad about it? Did it totally change? I mean,
I felt bad that it happened.
yeah.
I didn't feel bad about it.
You didn't feel that you were in the wrong.
No,
Yeah.
I mean, safety concern, yes.
But you had listened to him, right? When you.
I did at that point, yeah.
Yeah.
Yeah. It's just strange. And
Yeah.
just funny that one could feel he could exert that pressure over someone else's employee totally unrelated to his.
Yeah. Exactly.
That was kind
Yeah.
of strange.
I wonder if there was more going on than maybe even you realized.
Maybe.
Between, I don't know.
I mean,
there's always rivalries.
it's a
and things
different
between
era
people.
today. The whole safety thing might be viewed even differently today.
Yeah.
And it was pretty strict then as far as safety protocols.
Yeah. And maybe it was that, I'm just speculating here, but maybe it had bothered him all along.
He never knew it.
Oh, he didn't?
Oh,
Okay.
no.
Was this the first he'd ever seen
First
you?
he'd ever seen it.
Okay. It would just been in your office area that
Yep.
you'd been doing it before.
No, he would not have been aware of it.
Yeah. Okay. Yeah. Yeah. Well, it is an interesting story, and an interesting way to end your work, your time at a place.
So I had to go kill an hour's time before we met up with everybody at the restaurant.
So you did still get to see them at lunch, and
Yep.
you didn't just head home.
Got to say goodbye, and that was nice. And then I got home early,
right?
2:00 or something like that. And my wife's like, "Why are you home early?" I said, "Well, let me tell you a story." So it went ever since. If I ever show up early from work,
There's a little bit of trauma there now.
That reaction's there. Why are you home early?
Yeah. Wow, that is a great story.
Oh dear.
Yeah.
It's funny how stuff lives.
Mm-hmm.
So, transition. Yes, I started at ODG in 1994. And it was later that I learned that I was the last sort of the tag-on interviewee.
Right.
Interviewee. They were happy with how I answered the questions. They had little test questions. So because he wanted to know whether I had the technical ability to be in this case, the engineering manager.
Okay.
R&D manager.
Yeah.
So one was a little drawing of an Argo on a slope.
Okay.
And he says, and it showed the CG, the center of gravity for the Argo.
Okay.
So a classic little physics problem.
Mm-hmm.
And he asked, is there a risk of, is there a risk of rollover of that vehicle? Which, I mean, it's actually one of the ongoing concerns for the vehicles.
Okay.
I didn't know that necessarily, but I looked at it. And of course, I was pretty strong in that area with the master's degree, and during my master's program, I had done TA, teaching assistantships.
Okay. Yep.
For statics courses and dynamics courses. So you know how in school, when you take a course, you learn stuff and you cram and you write the exam and then you maybe don't remember it later.
Yep.
But the stuff from the year before is now firmly entrenched.
Right. Because you've kind of been building on it in your next set of courses.
And that's exactly how that was for me with statics and dynamics.
With your
stuff.
TA positions.
Because I had to TA it as in the master's program, that stuff was firmly entrenched.
Yeah.
I see things as free body diagrams.
Yeah.
So I, glanced at the page, drew a couple lines to communicate what I meant, and I said, "Yeah, I think you got a problem." Handed it back to him. And he really liked that.
Nice. Yeah.
And I didn't know that. But later he told me that. He says the other candidate was a young lady who was very gifted academically, technically, but she wrote this long analysis of this Argo on the page.
Oh, okay.
And that wasn't what he was looking for.
He liked your simple, direct approach, or
yes.
Yeah.
The other candidate, would have been a gifted person, everything else, but he needed somebody that was a little more informal about it. And it makes sense. It's vehicle development. You take them out, you rip them around, you test stuff. It's not strictly an office job.
Oh, yeah. Yep.
So I got hired there, started there. It was a smaller company than it is today, 50 people.
Okay.
I was replacing a gentleman, very gifted engineer, who quit fairly young, 50-ish or something like that.
Okay.
His wife was a dentist. They were immigrant couple, and she had to almost redo her whole dental accreditation.
Oh, wow.
She had been a dentist in Poland. And
okay, yep.
So he got her through that, and now it was her turn to do the income, I think.
Oh,
he
yeah.
supported her. But we also took advantage of his abilities on a contract basis.
Oh, and he did some consulting for you, kind
of?
Yeah.
He was a gear designer. I really wasn't and never did become one.
Okay, yeah.
That was one of the things the owner had said. He said, "You're going to have to get knowledgeable about gears." Well, I did, but not to the point of doing detailed design. So I inherited one employee. There was just the two of us in the engineering department, and had responsibility for developing the Argo vehicles.
Okay.
And supporting the plant with detailed specifications on all the things that go into the Argo, for example.
Okay.
So if something has to change, then we have to document that and keep track of it. That was kind of the job there.
So were there like design team that you would work with as well that would come up with ideas, or was that you as well?
We were it.
Yeah.
So as I said earlier, at 3M, it was a great place to start the career because you had this whole office full of people you could ask questions anywhere. And then at Argo, there were just the owner was a trained engineer and very gifted technically. And that was really helpful. We'd bounce ideas off each other all the time.
Yep.
And another colleague, good friend of mine, was he's an engineer and manager over the manufacturing, and not really a product designer, but very gifted on the manufacturing side and efficient ways of doing stuff. And so that was kind of it. It was a pretty small group to bounce ideas off of anymore. So I was really glad I had 5 years of working with other people and learning before that.
Was the Argo produced right there, like each one?
Yeah.
Okay.
That's what I didn't even realize when I was interviewed and hired. That was it. That's the world manufacturing location for that machine. And we should have got here earlier because I could talk all day on this.
Yeah.
It's a fascinating machine. There's at one point in the late 60s, before 3-wheelers and 4-wheelers became popular.
Right.
6-wheel, these guys were invented.
Okay.
And there's even a semi-legend about the inventor of them from here in Ontario.
Okay.
But probably did invent it, but probably wasn't able to make that transition into serious manufacturing.
Right.
There's totally different skills between inventing something and then becoming a business owner, and so
and scaling it. And
it's there's so much variety of skill needed to do all that,
Mm-hmm.
and money.
Yeah.
Which is where the different skill comes in generating the money.
Yeah.
So at one point in the late 60s, early 70s, at one point in time, I understand there were 69 different manufacturers of a vehicle similar to that.
Okay.
6-wheel amphibious vehicle.
Yep.
They were sold by Sears.
Wow.
There was, I can't say the name of it. A company in Elmira that made farm machinery. I can't say it. They had their own version of it.
Okay.
I even saw one stored in the back corner at New Hamburg somewhere. There was just so many of them. Mm-hmm. So by the time I started working there in 94, there were 2 left in the world.
Okay.
And the other one is in Buffalo, New York.
Okay. So it become a really niche market?
Well, it just had a huge falling out. Yes, because the 3-wheelers came on in the 70s. So Honda came out, and this is ancient history for you, but some of us that lived through that time, Big Red was a 3M 3-wheeler that started that whole process. And then all the other manufacturers got into it, Yamaha and Kawasaki and whatever, and that market expanded. And then in early 80s, there were lots. They were a dangerous machine, the 3-wheelers.
Right.
Because with a tricycle style vehicle like that, there are instabilities that happen dynamically during braking and turning.
Oh, okay.
So if you think about the physics of it, your center of gravity is where it is in the vehicle. Mm-hmm. But as you apply brakes, if you do it in a bit of a turn, you don't have a lot of support.
Okay.
And you'll do a roll to the right or the left, depending.
I see.
That type of thing.
So are 4-wheelers actually safer?
Oh, yeah.
Okay.
Big time.
Interesting.
Which is, as a little aside here, is why when you see these Bombardier Spiders, BRP, Spider motorcycle 3-wheelers on the road, they have 2 wheels in front and 1 in back.
Yeah. I've seen those,
The old school motorcycle 3-wheelers
are more like a tricycle.
Yeah. And they're really not safe.
Okay.
Like, you can ride them safely, but you have to take care. The Bombardier thing is as safe as being in a car.
Okay.
Partly because they put in electronics to limit the power you can apply in a turn.
Okay. I see. So are the 3-wheeler motorcycles with a 1 wheel in the front, are those actually less safe than a 2-wheeled motorcycle, like a normal one?
Yes.
Okay.
But you need the skill to ride a 2-wheel motorcycle.
Right.
Yeah. I would say so. So with the skill of riding a 2-wheel, so a term in this type of vehicle, off-road vehicles and on-road, is rider interactive vehicle.
Okay.
And a motorcycle is obviously a rider interactive vehicle. You have to interact with it for it to be safe.
Okay.
And Argo, not so much.
Okay.
You sit in it, you steer it.
Yeah.
The safety of it depends on the vehicle itself.
It doesn't require like lots of training to do it safely.
You don't have to watch where your weight is on it.
Yeah.
Somewhere between an Argo and a motorcycle are the ATV 4-wheelers.
Okay.
And that's the term rider interactive vehicle. And you have to learn how to use them.
Yeah.
So if you just sit on them and ride and go make a turn without doing the right lean or something, you're going to go flying.
Yeah.
So it's somewhat a snowmobile is a rider interactive vehicle. You have to be leaning into it and stuff. So.
Yeah.
Yep. So there was this in the 80s. They're down to 2 manufacturers.
Right.
And when I started in '94, the other guys are still there. I think they're still manufacturing, but they were never producing quite as many as Argo. I think Argo, it's funny, I still use the term we 5 years
Well,
later.
22 years, it's a long time to
Yeah,
be
it
thinking
is.
that
It
way.
was
Yeah.
a long time. Argo, I think, had the benefit of, well, they also made gears. So
Mhm.
they started as a gear company, hence the name Ontario Drive and
Okay.
Gear Limited.
Like gears for other
Other
companies or manufacturers
companies,
and
yep.
things. Yep.
That was a small part of the business when I started in '94,
Okay.
but they had a technical sales guy who was very good and wanted to grow that.
Oh, okay.
I think he was remunerated in a way that was his motivation too, which is fine. That's good.
Mm-hmm.
And so he pushed hard to grow that and did. And then we were, ODG was bursting at the seams in the late '90s. We rode the wave of the ATV movement.
Okay.
So after the three-wheelers stopped being sold, and they never got banned, but they did get voluntarily removed from the market by the manufacturers.
Okay.
Because of deaths and
I see.
safety
Wow.
concerns. So they quickly pivoted,
Mm-hmm.
new word for 2020,
Yeah.
to make four-wheelers.
Okay.
Wasn't a huge pivot, but they did that. And that market exploded.
Okay.
through
So the market got way bigger, which
It just exploded through the 90s.
Okay.
And Argo rode that wave.
I see.
Of course, we like to think it was because of the great products we developed. And it was. We worked hard at replenishing the designs and renewing them and making them better and everything else. But we really rode that wave. So from when I started there in '94, making $600 a year.
Okay.
By 2001, they're up to 2,000 a year.
Okay. Yeah.
The growth per year. So when I started, it was a $6 million company. When I left, when I left in 2016, 2016, it was a $60-70 million company.
Okay.
So it had grown 10 times.
Yeah.
On a gross sales point of view.
Yeah.
Sorry, I lost my thought. So yeah, we rode the wave of the ATV sales, and and then we were bursting at the seams in the late '90s.
Like manufacturing space?
Yes.
Or, yeah.
Just physical space.
Yeah.
And people and everything else, and the other guy had grown the gear business too. He was growing the percent. The gears were made for the Argo transmission.
Okay. Yeah.
And then he also sold gears and gearbox assemblies to other companies, and he was growing that to typically off-road mobile equipment. So think log skidders, sidewalk plows, company down in I forget, Tilsonburg or something that makes a sidewalk plow. Champion Road Graders in Goddard, which is there no more.
Okay.
Became Volvo. So it's kind of this interesting niche of small to medium volume off-road mobile equipment.
Yeah.
It's kind of neat. So in the late '90s, we were at a place where we have to build or do something to have room. And as funny as it sounds in hindsight, we didn't know how do we break up this company, or not break up, but divide it up to the manufacturer. Do we set up a new plant that just does assembly and people, and made the right decision at that time to build a new plant that did the gearing.
Oh, okay.
It seems like a no-brainer today.
Yeah.
Looking back, well, that makes sense.
So then you could take over the area with
just vehicle
the Argo.
Argo.
Yeah.
And that's exactly what happened then when the gear division, we officially started calling it a division then, vacated their part of the plant that had the machines in that cut the gears and did all that stuff.
Yep.
Then Argo could expand into that area.
Okay. Yeah.
That worked really well.
Were you part of that design process too?
No,
or?
not so much.
Okay.
I mean, I was on the management team to make those decisions, brainstorm how we're going to grow this business, do stuff. But the actual plant layout, my colleague was instrumental in working with architect and construction companies to do the new building to be appropriate for a gear plant. And the plant manager of the Argo plant was pretty gifted at layout and flow and setting up the plant there. Yeah. So that went well. Mm-hmm. One of the things about the Argo experience was the vertical integration of the business as a manufacturer and marketing company.
What do you mean by vertical integration?
So, vertical integration is a term used for describing how much of the work is done in-house.
Okay. Yep.
And it was fascinating at ODG that we basically bought steel, tires, chain, bearings, and raw plastic, and made a vehicle.
Wow.
And that was just a fantastic experience.
Yeah.
So they took raw steel, cut it, turned it, machined it, cut gears, teeth. We bought raw castings. We didn't wasn't a foundry.
Okay.
That'd be another step in vertical integration. Yeah. But
were you like stamping and things like that?
Yeah. We had punch presses, stamping, forming parts. Yeah, it was really cool.
Is that would you say from your experience that that's a good way? Like, is it better to do it that way rather than?
We'll talk about that.
Okay.
So even the cast aluminum housings came from the foundry in town.
Okay.
You know, I live beside my neighbor owns that.
Yeah. Yeah.
Now, it hasn't always come from there. Since then, it hasn't always come from there, but at the time it did. I think it still does today. Went back to them again.
Okay.
So you take a raw casting and put it on a machine and completely machine it, all the bearing pockets, face it, all precision stuff to put shafts and gears, bearings, make an assembly that's actually a transmission that makes the vehicle go. On the plastic side, we had raw sheets of polyethylene plastic that got formed in a vacuum forming machine to make the body of the vehicle.
Okay. And
responsibility for the design of that and the molds. I had avoided that area of the business for the first 8 years, 9 years.
Okay.
This is like one more specialty. I'm thinking, oh man, do I have to learn that too?
Yeah.
And well, I did.
Okay.
When we ran out of capacity on the equipment we had for the volume we were doing, we were deciding we got to buy new machinery. So being the engineer and being able to think critically about that kind of stuff, I did get involved.
Okay. Yep.
So I actually went and took a course for a week down in Atlanta.
Oh, wow.
Vacuum forming, and that was super helpful.
Yeah.
And then we went shopping for machines with the plant manager who had all the experience on the shop floor and knew it inside out that way. And together we were able to zero in on a brand of machine and spec it and buy it, install it, and make new molds. So I got involved in that. And even new model development. We got to a place where the old molds the vehicle had a tired look.
Okay.
And that's hard because that's a big investment.
Yeah.
To do a big new 10-foot by 5-foot cast aluminum mold. You know,
that's kind of a risky choice. Like if it's not liked or if it doesn't do well, or can you figure out some of those things ahead of time?
So that was another whole process in the R&D. Found an industrial designer. Didn't know what the term meant before.
Okay.
Industrial designer is basically a industrial artist.
Okay.
And didn't know where to turn, so different inquiries with different people that were in the industry. They directed us to this one guy, which turned out to be fantastic.
Oh, nice. Yeah.
He a little bit eccentric, but perfect for the job. Went to his place. It's up in Orangeville area, and he was a off-road enthusiast with old Army Jeeps and.
Oh wow! So he was like all into this.
It was such a good fit, and a gifted artist.
Wow! Yeah.
Designer. He had actually taught an Ontario Art School, taught industrial design for a couple of years too, and he's hands-on. He made prototype molds out of wood.
Oh wow! Nice.
Helped in and so he understood the process. He knew how to put the right draft the angles in so the parts could be formed and come off and all this stuff.
Okay. Yeah.
So that was a lot of fun. He actually went out and bought an Argo, used one, and fixed it up. And
Okay.
just to get in tune with it.
Yeah. Wow.
So that was fun. He would mock things up in styrofoam.
Okay.
Sketch first, like dozens and dozens of sketches, and we'd go, no. Oh yeah, I kind of like that. Can you put this hood on that body? And what about headlights? And in the sketch stage, then you'd mock it up in styrofoam.
Wow.
Glue slabs together, cut it with a big old carpenter's saw.
Like these full size?
Full size.
Oh wow. Okay.
Bring the front half of the Argo down to the vehicle, down to our place in his safari van, and set it on a lower body, and we'd stand around and look at it.
Fascinating.
It
Wow.
was so much fun.
Wow.
Yeah, and I remember one time we were zeroing in on the final look before we go to a prototype mold, and had these kind of oval headlights that you kind of had to. You had a lot of constraints because you weren't a big enough company to go develop every little thing.
Okay.
You
Yeah.
couldn't make a custom headlight. It's $80,000 for tooling
Yeah.
to do the left one, and then same thing to do the right. So
Yeah.
that wasn't really an option.
Mm-hmm.
So you gotta pick those things up front and then build around them.
Yeah. Yeah.
So he had this mock-up there with the headlight stuck in the pockets in the styrofoam, and standing around looking at it, and the owner's kind of looks like a frog. And he's not offended. He said, oh, no problem. We can change that. We'll do this, we'll do that. And so he went away and came back a couple of days later with it changed enough that it didn't look like a frog anymore.
Nice. Yeah. Uh-huh.
And then he committed that to wood that he made by hand.
Okay.
Big
Wow.
slabs of pine wood, carved it up, made a mold that we took to another shop that could form
Okay.
a prototype plastic part that we actually made an Argo we drove around in.
Okay. Wow.
And then once everybody's happy with that, then you commit to aluminum.
Okay.
and
Yeah.
Make the production.
So it's
molding.
quite a process.
It's
to,
a huge process
to come up with a new design.
Oh,
and
it's a big
implement
deal.
it, and
It's
yeah.
a big deal. And you can do now. You can do stuff all in CAD modeling,
Mm-hmm.
but generally you would go to a prototype mold for sure to make a part. You might even do a mock-up from the CAD data.
Okay.
A designer can do it all in 3D modeling, but you would still want to
be able to see
somebody cut it out physically to look at it, or go directly to a mold
it. Okay. Yeah.
and make parts that you can drive and test and stuff.
Mm-hmm.
So the vertical integration, yeah, is plastic forming, machining gears, the assembly of the vehicles,
Mm-hmm.
and of course and then the marketing and sale of this stuff,
Mm-hmm.
whole dealer network. That they were independent dealers, but they would sign up as an Argo dealer.
Okay.
So they
Yep.
weren't, and the company would sell the vehicles to them at a dealer price. They resell it for
Okay.
a retail price. We actually had a 3-tier structure: distributors
Mm-hmm.
throughout North America, well, around the world actually,
Okay.
and then the distributors were responsible to find dealers to promote the product.
Oh,
So it
yeah.
was-
Mm-hmm.
yeah, it was fascinating. We'd have a biannual, like every 2-year, distributor meeting.
Okay.
Got to meet these guys from around the world.
Mhm.
There's distributor from England, from Australia,
Oh, wow.
New Zealand, Europe, Russia,
Hmm.
and of course across U.S. and Canada.
Yeah.
That was neat. That was fun.
Mm-hmm.
That was a chance to showcase new product and learn about stuff happening in their areas.
Yeah. So you said you would talk a little bit about the advantages, and maybe that's what you were getting at with
Oh.
that. But like, what would
Okay.
you have lost if you would have
Yes.
subbed out all of that manufacturing and just brought in a few things to
Yep.
put together?
Perfect question. And that would be a common way that companies today, car manufacturers,
Yeah,
and
like
stuff do
Toyota
stuff.
has
They have
tons of
tier 2, tier
other-
3
yeah.
suppliers.
yeah.
I can't speak for them. I'm sure it works for them.
Mm-hmm.
I mean, what you get in value in a vehicle that you buy to drive on the road is just incredible.
Yeah, yeah.
They're expensive, but the technology that's in them is unbelievable.
Mm-hmm.
It's also related to volume. When you make
Yeah.
$1 million of something,
Yeah.
25-cent savings on something is worth
year.
spending 2 years to figure it out.
Yeah.
There were times when we had to make a decision. Do we order this stuff outside or do we make it in-house?
Right.
If we had the capability to make that choice, then we had to make the decision. Do we make it in there or buy it out? And almost always it would have been cheaper to make it in-house if we have the capability and the capacity to do it.
Okay.
Yeah. It was, and part of the reason is if you buy it from somebody else, they have to make some margin.
Right.
You
Yeah,
know,
that makes sense.
when you do it in-house, you're looking at your costs to do it, labor, material,
Yeah.
a bit of overheads, that kind of stuff. That's your cost. You don't have to add on 15%.
Yeah.
They do, and they will, and you're going to pay it.
Yeah. Yeah.
So when you're evaluating make in, buy out, almost inevitably it was better to make it in if we could and had the capacity.
Are you weighing like how much it's going to cost you to set it up and
you gotta
research it?
You got to have accurate costs for everything in house, and that's
Right,
impossible. But you do the best you can, and you make it as good as you can, and that led to issues because sometimes the amount of overhead applied to a particular item, you don't know how much floor space does that part cost.
Yeah.
You know, whatever, or heat and hydro and all this stuff. If you farm everything out, everything you keep in, suddenly overheads go astronomical.
Yeah.
So these are the challenges. But you sort of keep that all in your mind when you're looking at it. And if you could make it in-house and you had the capacity, it was way better to do it.
Okay.
And you had control.
Yep. Yep.
Or you couldn't blame anybody else when delivery wasn't on time.
Yeah. Yeah. Oh, it's fascinating to think about. It's a term that I've been hearing a little bit of, like it's talked about, especially referring to like some of the things that Tesla's doing and stuff like that. So I just when you brought it up, I was like, oh, that's fascinating. I didn't realize that you would have had experience with your the work experience you had there at ODG. That's something that they focused on and did. So that's fascinating.
And that's where you and I have had some of the conversations about Tesla, and without knowing where my opinions are coming from, it's obviously from stuff like that. Just the time it takes to learn to do stuff. I am amazed that Tesla's done what they've done, and I don't know if they've pulled in experience from the automotive world. I get the impression not, that they're working with young people that are keen and eager and ambitious. But it is amazing that they've done what they've done without that decades or century of automotive experience. I mean, on the one hand, they say, well, they don't want that baggage.
Right.
On the other hand,
there's a lot of efficiencies in that.
Still takes 20 years to get 20 years experience.
Yeah, it'll be interesting to see in the next decade or so if it totally disrupts the way that cars are produced, or if it kind of is a thing that kind of falls to the wayside. But anyway, we're quickly getting to our 2-hour mark here, so we'll have to kind of decide what we want to spend the next little bit on. But maybe I'll just ask that: is there another story or something from your time at ODG that you wanted to make sure to say here? So in the next couple minutes, before maybe a few more general questions about your experience.
Not so much. I did want to focus what we talked about there on the vertical integration, the manufacturing stuff. More on a maybe a amusing level here is my recollection of the years in history of my career there come down to the introduction of the new models that happened.
Okay.
95 was the Vanguard, 97 was the Response, 99 was Centaur, and the owner made a amusing comment at one of the distributor meetings. One of my employees had been key in bringing the one vehicle to market, and I'll probably use his name. He said, this is John and his wife just had a baby, but I think he's going to remember this baby. And that stuck with me because men don't have babies, women do, and they do remember the years, the points in history around those events.
Right, yeah.
And I remember things around the introduction of new vehicles. 'Cause
Yeah.
a lot of effort goes into that. And
you put a lot into it.
And they're highlight. It's a highlight even if things go bad.
Okay, yeah.
Yeah,
to kind of get that to fruition. Just maybe along with that, that's something I was curious about. When you would bring out a new design, like you talked about there, you mentioned some of the names. Would that mean that the whole plant would switch to those and your whole line would become that?
No. The lineup of vehicles would include probably half a dozen different models.
Okay.
But we'd try to have a new one every 2 years that would replace one or a shared features of one. So we'd have 3 models that are kind of the same body shape and stuff, that different engines, that kind of thing.
Right. Oh, so you had some variety within your different lines. Yeah. Yeah. Fascinating. Yeah. So there's a couple of things that I thought might be interesting to talk about just a little bit generally, and I'll leave we'll leave the last couple minutes for if you have any advice. But before that, I didn't know if you had anything to say back on question 3A that I had there. What skills and ways of thinking are needed to be an engineer? And maybe you've been talking somewhat about that as you've gone along, but do you have a specific answer to that question about, from your experience, what are some of the specific skills and ways of thinking that are needed for an engineer?
Yeah, I what came to my mind was sort of logical, technical, realistic.
Yep.
I don't know.
It's got to work. Right?
I don't know. I don't know if that's universal, but you got to be realistic about it. I would say engineers tend to be more that way than maybe sales and marketing people. Sales and marketing people would be creative and optimistic, and which is important. Important for all of us, but when you don't have the technical background to understand something, you can be unrealistic in your optimism.
Oh yeah. And does that come into what's possible for
absolutely,
for a vehicle to do, or is it
absolutely?
Does it also come into the how much time it's going to take to develop a new
all
vehicle?
Of that.
Yeah. Okay.
Yeah. You would recall some of the conversations we've had, I'm sure, in the past. But
yeah.
And detailed. So you got to be detailed. You will have responsibility for whatever it is you're working with.
Okay.
No one else is going to take that responsibility. If you're the one that's responsible for something working, you gotta cover the details.
Okay. So
that's important.
When you say that, I'm thinking about like things like safety and stuff like that. Is that what you're thinking?
I'm thinking about the specifics of the design of a part, the manufacture of it, the assembly of it, the performance of it. Yep. All this stuff is kind of rests with you.
Right. So if something doesn't work, it comes back to, was it designed, engineered properly? Yep.
Yep.
Yeah. Did you have more to say on that, or more things that you had down for skills needed, ways of thinking?
Probably not right now. No.
We talked about some of the different. I mean, would you call yourself a mechanical engineer? You said you'd taken agriculture engineering in your undergrad.
Yeah. So for a professional engineer, and I didn't explain some of that. A professional engineer in Canada requires a 4-year degree and passing a law and ethics professional practice exam and 4 years of experience.
Okay.
Now, at the time I graduated, it was 2 years, but that's the requirements for a professional engineer in Canada.
Okay.
And the degree has to come from an accredited university in Canada.
Okay.
And there are lots of them, but they need to pass accreditation to be eligible, or to provide a degree that's eligible to be a professional engineer.
Okay.
There are other engineers that train at college level, 2-year, 3-year programs, technician, technologist, but they're not professional engineer. Some of the differences are subtle.
Okay. Is
But
there like certain things that require a professional engineer to sign off on or something? Or
yes.
where does that come in?
So a professional engineer gets a stamp that can seal documents. It's generally used for civil type engineering, buildings, bridges, even geotechnical work, foundations of stuff.
Okay. Is it mostly related to the safety features of
Yes,
things?
it's all about protecting the public safety.
Yep.
And ensuring that it's going to work, it's strong enough.
Okay.
So I have not used my stamp much. I think I did for rollover protective structure design for the Argo ROPS. And I didn't actually do the design. My employee did, but he didn't have his PNs at the time. I reviewed it. I stamped the documents.
Okay. So you would be the one that's responsible if for some reason that would fail or something.
The guy that goes to court if there's a lawsuit.
So you listened to my conversation with Lester in the designing. Like he talked a little bit about needing some engineered drawings for some of the things that they do. Is that the same thing you're talking about here?
Yep, that's exactly it. So I listened to his interview there, and in a building, a lot of stuff is covered by a building code.
Right.
And as long as you stick within that code, you're covered for the design of that building.
Okay.
As soon as you stray from that in any way, then somebody's got to sign off on the design. Now, I'm fully confident Lester and lots of other people, even the construction guys, builders, know what's needed for a beam through the bottom of a house.
Yeah.
But it's also a simple thing then to run that sketch design past a PNG to review, put his stamp on it, fire it back to them, and they're good to go.
Right.
So that's what that's about.
Okay. Yep.
And then you get into buildings that just are not part of a building code. So the feed mills we do. There's no building codes to cover that. I mean, there's lots of building code aspects to it.
Right.
Access to the building, egress, fire codes, how proximity of doors to stairs, and just a whole host of stuff that they have to be aware of. But as PNGs that do that kind of work, they have to make sure that meets the code. Yeah. But the structural design, they take responsibility for.
Okay. Yeah. Yeah. Very good. Yeah. Maybe we'll spend the last couple minutes here seeing if you have any advice then. So my first question along those lines are, and this is, I guess, thinking for everyone here, are there ways that you use or benefit from your engineering expertise in your life outside of your work? So I from what I know of you, I know that you seem to think like an engineer in a lot of different things. So did you come up with any ways that you benefited?
I jotted a couple things down. Yeah. So I think one's able to more easily research things.
Okay. Yeah.
But I think that's for anybody. The more one learns, the easier it is to learn.
Right.
You know, you have a bigger, broader base.
For sure.
To look at something. I wrote this down. It can make one skeptical of things.
Okay. Yeah.
And that can be viewed negatively by people, but you can't help it.
Yeah. And what are you meaning by that? Or
when you know the physical limitations of the world around us, and even then when you are presented with something or see something, you kind of go, like, that doesn't mesh with what I know about the physical world or whatever. Yeah. And it actually, this can be in a good way extends to people too. I thought of this, that it's not about being an engineer necessarily. It's about having knowledge and education and life experience to realize that without as much knowledge or life experience, and maybe to a lesser extent even education, I think one is more susceptible to conspiracy theories and being suspicious that some high-level person out there is orchestrating the events of my life. Right. And the more one has of just life experiences and knowledge and to some extent education, I think you realize that they're not really getting it either. There's nobody out there that's so smart
Yeah.
or so able that they can orchestrate anything.
Yeah.
They're just people.
Yeah.
People like you and me, and so I think that's helpful. How to communicate that
Yeah.
to other people is always a challenge.
Yeah. When you were talking about how sometimes you can benefit from skepticism as far as knowing having somewhat knowledge of how things work. Do you see that too in like maybe a product that's advertised or something like that? Did you have that in mind?
Sure. Yeah.
Like,
Yeah.
and you
But
kind of know that.
I don't know if that comes from engineering background or just life experience, and
I'm sure it's some of both too.
I think it is
there too. Yeah.
I was going to say you tend to analyze things from an engineering point of view. We talked about forces, strength of materials.
Yep.
I thought of this one. I had to go look up the term for it because what came to my mind was energy can neither be created nor destroyed, just converted from one form to another. I remembered those words verbatim.
Yeah.
I didn't remember what it
You
was.
didn't remember the term?
It's the law of conservation of energy.
Yeah. Yeah.
So it's funny how stuff gets entrenched in your mind when you
principles. Yeah.
studied it.
Yeah.
And that's a big one, right? You look
Yeah.
at something.
Yeah. I've heard it described in physics as there's no free lunch.
There's no free lunch.
You always have to get the energy from somewhere, and
If the
yeah.
electric car battery is 93% efficient, the other 7% is going into heat.
Yeah.
Going up in smoke, maybe.
Yeah. Yeah. Yeah.
So it's stuff like that.
Yeah. Very good. I was thinking, so just from my experience with you, I remember canoeing with you one time. And I was in the front of the canoe, and I remember you like talking the whole time about how you're always trying to find the best way through maneuvering through the rocks or rapids to expend as little energy as possible, and
Can you
things
imagine
like
how
that.
annoying that is to the people around you?
Yeah, I'm sure some people do, but I love it. Like I love thinking about those kinds of things, and Joy is always telling me like ways that she can like. This is how you drive the car efficiently, and that kind of thing that she's learned from you, and just part of growing up with you.
I used to
like
tease
that.
them. I said, "You're gonna hear my voice in your head for a long time."
Oh yeah, it sticks after you're parenting someone for 20 years. That's for sure. Yeah, just a couple minutes here on. Do you have advice for engineers that are starting out on the field, or someone that's maybe thinking about, interested in becoming an engineer? Is there anything you'd like to say to them from your experience?
Yep, I think that's a good question for here. To those that might have an interest or thinking about it, my thought would be become friends with math and science.
Yep.
I know you've used the term, I think it came from your mom, books are our friends.
Yep.
I said, well, numbers are our friends.
Yeah. Yeah.
Because if that isn't the case, you probably don't want to go into engineering.
Right.
You gotta become friends with math and science. And to those that are starting out in engineering, technology, or whatever, I would have this advice: ask questions. And just as important as ask questions, make sure you have someone willing to answer the questions, because that's not always the case. Most times people feel honored to be asked questions and they like to answer them, but sometimes people are just too busy.
Yeah.
And so that's important. I was fortunate at 3M to have a whole office full of people, and that was very helpful.
Yeah, no, that's great, and yeah, thanks for sharing your experiences and the things that you've learned along the way, and things like that. Just as a final thing, I'd like to ask my guest if there's anything kind of that I didn't have a chance to talk about that you just wanted to for sure say, or if there's anything that you wanted to promote before we ended here. So anything that you'd like to say before we wrap up.
Yeah. Okay. There's lots more to talk about, but
oh yeah, maybe we'll have to have you back again.
I'll take the opportunity to do the promotion thing, and I talked to the owner of CAMR on this too, and I think I'd like to suggest that, well, we'd like to recruit at CAMR. And so if there's people that would have an interest in ag industry, feed mills, grain terminals, and would have an interest in that kind of thing, I'd really encourage them to take a look at the website that Camar has. It's
Okay.
CAMAR, camar.ca.
Okay.
Really cool website with neat drone aerial video of some of the projects that have been done.
Mm-hmm.
Can't really show the detail of the guts of those projects.
Oh, yeah.
But that's all there. And I know Jamie had talked a few weeks ago about the automation. So there's two sides to the business, automation and the actual design of the big projects. So if there's someone that would have an interest in that kind of career, the website has a careers section on it.
Okay.
With some job descriptions.
Mm-hmm.
They look pretty intimidating.
Mm-hmm.
Obviously, it would be beneficial to have somebody with education, technologist or engineer.
Yeah, I was going to ask, are you looking for specifically trained engineers here?
It's on the website there, and we do say it that way,
Mm-hmm.
and that would be nice
Mm-hmm.
with experience. But just as valuable would be people that have a serious interest to pursue that kind of thing
Mm-hmm.
with a technical bent,
Mm-hmm.
and are just willing to learn, work hard. Take a look. It would be.
Yeah.
That would be kind of it, I think.
Yeah, very good. All right. And I'll link that website you mentioned in the show notes as well if someone wants to check it out further. So yeah, thanks a lot for coming and sharing with us here today.
You are welcome.
Thank you everyone for listening, and thank you Brian for sharing your knowledge with us. I really enjoyed this conversation, especially hearing some of the stories that he shared and some stories that I had never heard before. And it was great to hear a little bit more about his experience and some of the things he had to share. I especially liked the advice to not be afraid to ask questions of those around us, especially when we're getting into something new and when there's people around that are willing to offer their help, their advice, their assistance. And I think about this as a student where I'm often kind of tentative to reach out and ask for help when I really could. So I really enjoyed that advice and those suggestions to reach out to those that are willing to help us. So yeah, thank you, Brian, for coming and sharing your experiences and knowledge with us. If you'd like to learn more about this episode or other episodes, check out the website, everydayexpertise.ca. If you have feedback for me or would like to reach out for any reason, best way to do that is to send me an email. The email address is contact@everydayexpertise.ca. That's all for now. Join me again next week to learn from the expertise of everyday people.